Hello friends, welcome to my channel Academic Made Easy PC. If you have not subscribed my channel, subscribe it and also click the bell icon. In this video, we will be learning exercise 4.6 from the chapter Determinants of class 12 CBSE. In this exercise, we will be learning the consistency and inconsistency of system of equations and finding the solution for the given equations, that is linear pair equations. So now let's move on to the questions. Examine the consistency of the system of equations. So here we have to just check whether it is consistent or inconsistent. So I have taught you what is consistent and inconsistent. No, consistency means it has one or more solutions. Inconsistent means it does not have any solutions. Question 1. Two equations are given and we will be finding the consistency or inconsistency of this equation. So solution, first we will be writing the matrix form for this. So here now I will be just taking three matrices, that is A, B and X. So my matrix A contains the coefficient of the variables, that is coefficient of X, here it is 1 and here it is 2, coefficient of X 2, coefficient of Y is 3. So this will be my set A. So now I will have my X as, what are the variables present over here? X and Y. You have to write first variable here and second variable. Don't change the order. And my matrix B is equal to this one, this part. So 2, 3. So these are the required matrices. So now I will be just checking the consistency. Consistency, you just want to check the determinant of A. So if determinant of A is not equal to 0, then you can directly say that it is consistent. If the determinant of A is equal to 0, then you have to find the adjoint of A and you have to multiply it with B. So if that is equal to 0, then it is consistent. If it is not equal to 0, then it is called inconsistent equation. Okay, so here first let me find the determinant of A. So determinant of A is equal to 1, 2, 2, 3. So for this I will be using the X method. So determinant A is equal to 1 3s are 3 minus 2 2s are 4. So determinant A is equal to minus 1. Since determinant A is not equal to 0, I will say that the solution for the given equations is consistent. That's it. Question 2, two equations are given and for this also we have to find the consistency only. So now first we will be finding the matrices. So let my matrix A is equal to the coefficient of the variables. So 2 minus 1, 1, 1. I have taught you more clearly in the introduction part. If you have not watched that video, I will attach the link in the description box. Watch it. So my next matrix is X. So I will be writing the given variables. So X and Y. And my third matrix will be my B, which is 5 and 4. Now in order to check my consistency, I will just take the determinant of A. So 2 minus 1, 1, 1. So now I will be using the X method in order to find. So 2 1s are 2 minus 1 into minus 1 is minus 1. So therefore 2 plus 1. So determinant of A is equal to 3, which is not equal to 0. Therefore, the given equations has the consistent solution. So next, three equations are given. So till now we were seeing 2 equations. No, so now from now we will be seeing 3 equations. So for these 3 equations we have to check whether it is consistent or not. So solution. First, let us take the matrices. So, matrix A is equal to, I will be writing the coefficient of x, y, and z. So, 1, 1, 1, 2, 3, 2. So, this column will be for x, this column for y, and this for z. So, A, 2A. So now I will be taking for x. So x will have x, y, and z. So next we will be taking for b. So b will have 1, 2, and 4. Now to check the consistency, we will be just taking the determinant A first. So determinant A is equal to 1, 2A, 1, 3A, 1, 2A, 2A. So now what I will do is that I will be taking this A out because A is common everywhere. No, so I will be just taking the A out. So determinant A is equal to A into determinant 1, 2, 1, 1, 3, 1, 1, 2, 2. So this is 1. No, so I will be just subtracting these two columns. Okay, so in order to get my answer 0 over here or else here. So let me take it over here. So column 3 implies column 3 minus column 1. So determinant A is equal to A into, so 1, 2, 1, 1, 3, 1. 1 minus 1 is 0, 2 minus 2 is 0, 2 minus 1 is 1. So here I can expand through this column. So expanding through the column 3. So determinant A is equal to A into, so this is 3 position. So since it is even, I will take 1 as it is. So 1, 1, 1, 2, 3. So now I will just take through x method. So A into 3 minus 2. So determinant A is equal to A. So since it has some value whereas it is not equal to 0, no, so therefore I will say that the given pair of equations are consistent. Now the next 3 set of equations are given and we will be finding the consistency or inconsistency of this equation's solution. First, as the standard method, we will just take the 3 matrices, that is A, X and B. So matrix A is equal to the coefficient of these variables. No, so my first column will have coefficient of X, next Y and next Z. Okay. So this is my matrix A. So now let's check for X. So we have 3 variables, no, X, Y and Z. It is in an order, so have it in an order only. And my matrix B is equal to my RHS. So 2 minus 1, 3. So now in order to check the consistency, I will just take the matrix A, determinant of the matrix. So determinant A is equal to 0. So if you check in this column 1, I have 3 common, isn't it? 3 ones are 3, 0 3s are 0, 3 ones are 3. No, so I will just take this 3 outside. So determinant A is equal to 3 into 1, 0, 1, minus 1, 2, minus 2, 2, minus 1, minus 5, 0. So this is my matrix. So now I will just expand through this column since I have 1, 0 and it will be easy for me to do the calculations. So determinant A is equal to, I will be expanding through column 1. So 3 into 1 into 2 minus 1 minus 5, 0, plus 1 into minus 1 minus 2, 2 minus 1. So now determinant A is equal to 3 into, so I will be using the x method, so it is minus 5 over here plus 1 plus 4. So determinant A is equal to 3 into minus 5 plus 5. So determinant A is equal to 3 into 0. So determinant A is equal to 0. So now I just have to check the adjoint, isn't it? So adjoint of A into B. So now I will be finding the adjoint of A. So adjoint of A is equal to, so now this is the adjoint. So now let's find for adjoint A into B. For adjoint of A into B. So what is my adjoint A? Will be multiplying these two. So this is of the order 3 by 3 and the second one is 3 by 1. So I will be cancelling these two. So 3 by 1 matrix is my final matrix. So adjoint A into B is equal to, so now I will be multiplying. So adjoint of A into B is equal to, so minus 10 plus 15, it is minus 5. So here minus 6 plus 9. 12 minus 9 is minus 3. So minus 12 to minus 24 plus 18, it is minus 6. So which is not equal to 0. Therefore, I will say that the system of equations is not consistent. That is inconsistent. It is nothing but we will be finding the determinant of A first. So if determinant of A is not equal to 0, then directly we will say that it is consistent. So if suppose determinant of A is equal to 0, then we will be finding adjoint of A into the B matrix. Okay, so if this is equal to 0, then it has consistence. Okay, if it is not equal to 0, then we say that it is inconsistent. That's it. Solve the system of linear equation using matrix method. So till now we were seeing only the consistency of the equations. No, so from now we will start finding the solution for these system of equations. Okay, so using matrix method, I already taught you the formula. So using that formula we will be finding. So first let us write the matrix. So here we will be changing these equations to matrix. So the coefficient of the variables will be one matrix and the variables will be in one matrix and the solutions here will be in one matrix. So 5, 2, 7, 3. And my next matrix will be with variables. So x, y. And my next is b is equal to 4, 5. So these are the required matrix. Now I will just find the A inverse. Okay, so what is the formula that we will be using? X is equal to A inverse B, isn't it? So in order to find that, I will be finding my A inverse. So my A inverse is equal to 1 by determinant of A into adjoint of A, isn't it? So now I will be finding my determinant of A first. So determinant of A is equal to 5, 2, 7, 3. So using the x method, so 15 minus 14 is equal to 1. This is not equal to 0, no? So I will say that therefore inverse exists. So now I will be finding the adjoint of A. So if we just check here, this is a matrix, isn't it? So we will be swapping these two elements. So A11 and A22, no? So A22 will be here, A11 element will go here. So now I will be changing the signs for the remaining elements. So -2, -7. So my A inverse is equal to 1 by 1 into adjoint. So that is 3 -2 -7, 5. So this is my A inverse, and now I will start finding the answer, that is solution. So x is equal to A inverse B. So what is my matrix X? Xy is equal to A inverse is 3 -7 -2 5, and what is matrix B? 4 5. So xy is equal to, so now I will be multiplying these two. So my first matrix is of the order 2 by 2, and my second matrix is of the order 2 by 1. So 2 and 2 will get cancelled. So 2 by 1 is the final answer. So 3 minus 2, I will be taking only once. Why? Because I have only one column. So -7 plus 5. So 4 into 5 and 4 and 5. Okay, so A inverse, here it is 1 by 1 only, no? So only just like that I took. I didn't take this one here. So my xy is equal to, so 3 fours are 12, 12 minus 2 fives are 10. So 12 minus 10 is 2. And here it is 7 fours are 28. So -28 plus 25 is -3. So the answer for x and y, so x is equal to 2 and y is equal to -3. These are the required values for x and y. So the next question, so two equations are given. So from this equation we have to find the solution for x and y. So solution, as we do it, so first we will be finding the matrices A, X and B. So the matrix A will have the coefficient of variables. So now I will take, so 4 -3 3 -5. So next matrix will be for the variables. So x is equal to xy and my b is equal to this answers. No, so 3 7. So now I will be taking the determinant of A. So 4 -3 3 -5. So I will be taking the determinant. No, so using the x method, I will have -20 plus 9 is equal to -11. So this is the answer, and this is not equal to 0. No, so therefore inverse exists. Now I will start finding my adjoint of A. So adjoint of A is equal to, see here I will be swapping A11 and A22. So my A22 element is -5, A11 is 4, and I will be changing the signs for the remaining. So -3 will become +3, +3 will become -3. So this is the required adjoint of A. So A inverse is equal to 1 by determinant of A into adjoint of A. So A inverse is equal to -1 by 11. -11, I'm just writing it as -1 by 11 into, what is the adjoint? -5 -3 3 4. So this is the required answer for A inverse. Now I will be finding for x, x is equal to A inverse B. So what is my x? X and y. So my matrix A inverse is -1 by 11 into -5 -3 3 4. And my matrix B is 3 and 7. So xy is equal to minus 1 by 11. I will be multiplying these two. So this will be of the order 2 by 2 into 2 by 1. So I will be cancelling these two. So 2 by 1. So minus 5 plus 3, minus 3 plus 4. So 3, 7, 3, 7. So now I will start multiplying. So xy is equal to minus 1 by 11 into minus 15 plus 21. It is 6, and here minus 9 plus 28. It is 19. So what will be my answer? X, y is equal to, I will be taking this inside. So I will have minus 6 by 11 and minus 19 by 11. So my x is equal to minus 6 by 11 and y is equal to minus 19 by 11. That's it. These are the required values for x and y. So next question. Here also we have to find the solution only. So here 3 equations are given and we have to find the solutions for these 3 equations. So what I did is that I took the 3 matrices A, X and B. A contains the coefficient of the variables, X contains the variables, and B contains this solution for these equations. So now let us start. First, we will be finding A inverse. Now, in order to find the A inverse, we have to find a determinant of A first. So, determinant of A is equal to 2, 1, 1, 1, minus 2, minus 1, 0, 3, minus 5. So, I will be expanding through the column 1. So determinant A is equal to 2 into minus 2, minus 1, 3, minus 5, minus 1 into 1, 1, 3, minus 5. So determinant A is equal to 2 into 10 plus 3, minus 1 into minus 5, minus 3. So determinant A is equal to 2 into 13 is 26 minus 1 minus 8. No. So determinant A is equal to 26 plus 8 is 34. Since this is not equal to 0, I will say that therefore inverse exists. So next I will be finding the adjoint of A now. So adjoint of A is equal to 13, 8, 1, 5, minus 10, 3, 3, minus 6, minus 5. So this is the adjoint of A. So now let's find for A inverse. A inverse is equal to 1 by determinant of A into adjoint of A. So therefore A inverse is equal to, what was my determinant? 34 into the matrix is 13, 5, 3, 8, minus 10, minus 6, 1, 3, minus 5. So now let us start finding the answer. So x is equal to A inverse B. So x is equal to, what is my A inverse? 1 by 34 into 13, 8, 1, 5, minus 10, 3, 3, minus 6, minus 5 into my B matrix is 1, 3 by 2, 9. Okay, so now let me find the order. So 3 by 3 for first matrix and 3 by 1 for the second matrix. So these two will get cancelled. So what is remaining? 3 by 1. So now we'll start multiplying. So what is x? X, y, z, isn't it? So it is equal to 1 by 34 into 13 plus 8 plus 1, 5 minus 10 plus 3, 3 minus 6 minus 5. So I will multiply with the second matrix. So 1 3 by 2, 9. So now here I can cancel. This is 3, 5, 4. So x, y, z is equal to 1 by 34 into 13 plus 12 plus 9, 5 minus 15 plus 27, 3 minus 9 minus 45. So x, y, z is equal to 1 by 34. So 13 plus 12 it is 25. 25 plus 9 it is 34. And here minus 10 minus so 17. So here minus 6 it is 51. So minus 51. So x, y, z is equal to, I will be taking this 34 inside. So 34 by 34 it is 1. 17 by 34 it is 1 by 2. And minus 51 by 34 it is 3 by 2. Okay, so minus 3 by 2. So this is the answer. So now x is equal to 1, y is equal to 1 by 2 and z is equal to minus 3 by 2. So these are the required values for x, y and z. If A matrix is given, then find A inverse. So till here, part 1. Using A inverse, solve the system of equations. So next we will be taking this one. So first let us find the A inverse. So before that, and one more thing I would like to say is that, see, if you just see the coefficient of x, y and z, see, we will be taking this as A, no, matrix A. The same thing is given. So that is A matrix is given. That is the coefficient of the variables is only is given over here. And we have to just find x and b and then we can start doing. So first we will find for A inverse. So before that we will try to find the determinant. So minus 3, 5, 3, 2, minus 4, 1, 1, minus 2. So now let's start finding. So I will be expanding through the row 3. So expanding through R3. So determinant A is equal to, so determinant A is equal to minus 1. So now let's find for adjoint A. So adjoint A is equal to 0, minus 1, 2, 2, minus 9, 23, 1, minus 5, 13. So this is adjoint A. So now A inverse is equal to 1 by determinant A into adjoint of A. So now A inverse is equal to minus 1 into, what is adjoint? 0, minus 1, 2, 2, minus 9, 23, 1, minus 5, 13. So now first part is over. Okay, so now second part, that is solving the system of equations. Now, so x is equal to A inverse B. So what is my x? X, y, z is equal to minus 1 into 0, minus 1, 2, 2, minus 9, 23, 1, minus 5, 13 into, what is b? B here it is 11, minus 5, minus 3. So now x, y, z is equal to minus 1. I will keep it as it is. And here this is of the order 3 by 3 and 3 by 1. So here cancelling these two, 3 by 1 is the final order. So x, y, z is equal to minus 1 into 5 minus 6. Here it is 22 plus 45 minus 69. Here 11 plus 25 minus 39. So x, y, z is equal to minus 1 into minus 1 minus 2 minus 3. So now I will be taking this minus 1 inside the matrix. So x, y, z is equal to 1, 2, 3. So the value of x is equal to 1, y is equal to 2 and z is equal to 3. These are the required solution for this equations. So this is important 6 marks question. Very important 6 marks questions. We may get these types of questions for 6 marks, mostly for 6 marks or else for 4 marks. This is sure question from this exercise. Next question. The cost of 4 kg onion, 3 kg wheat and 2 kg rice is rupees 60. Okay, so the cost of 2 kg onion, 4 kg wheat and 6 kg rice is rupees 90. The cost of 6 kg onion, 2 kg wheat and 3 kg rice is rupees 70. So find the cost of each item per kg by matrix method. So now see here, if you carefully look into this, there are 3 products that is given. 3 products, that is onion, wheat and rice. So these are the 3 things that are given and this is the after equation, that is a solution for this. And here also 3 is given, here also 3 is given, isn't it? So we will be taking 3 variables for these 3 different things. So solution, I will take let x comma y comma z represent the cost per kg for onion, wheat and rice respectively. So now x represents the cost of onion per kg and wheat represents, y represents for wheat and z represents for rice. So now let's start writing the equation. So here see 4 kg, 4 kg of onion, 3 kg of wheat and 2 kg of rice is equal to 60 rupees. Now I will write the equation as 4x, 4 onions, 4 kg onions, so 3 kg wheat plus 2 kg of rice is equal to 60. Next 2 kg of onion plus 4 kg of wheat plus 6 kg of rice is equal to 90 rupees. 6 kg of onion plus 2 kg of wheat plus 3 kg of rice is equal to 70. So these are the 3 required equations. So hereafter it is going to be same as we did for the previous sums. So first let us take the different matrices, that is A, B and X. So my matrix A is equal to 4, 2, 6, 3, 4, 2, 2, 6, 3. And my X is X, Y, Z. And my matrix B is equal to 60, 90, 70. First, I will be finding the A inverse. So, For A inverse, I will be finding determinant of A first. So determinant of A is equal to 4, 2, 6, 3, 4, 2, 2, 6, 3. Okay, so now I can't do any simplifications. I mean, there's no simple method to do, so I have to expand through some rows or columns. So let me take row 1 itself. So I will be expanding through row 1. So determinant A is equal. So determinant A is equal to 50. So since this is not equal to 0, therefore inverse exists. So adjoint of A is equal to, now let's find adjoint of A. So adjoint of A is equal to 0, minus 5, 10, 30, 0, minus 20, minus 20, 10 and 16. Now this is my adjoint of A. So my A inverse is equal to 1 by determinant of A into adjoint of A. So A inverse is equal to, what was my determinant A? It was 50 into adjoint of A is 0, 30, minus 20, minus 5, 0, 10. 10 minus 20, 16. So now I will be finding my x. So A inverse B. So x, y, z is equal to 1 by 50 into 0, 30, minus 20, 5, 0, 10, 10, minus 20, 16 into my matrix B is 60, 90, 70. So now this is of the order 3 by 3 and this matrix is of the order 3 by 1. So now my final matrix will be of the order 3 by 1. So x, y, z is equal to, I will be taking this 50 inside. So I will have x, y, z is equal to, zeros will get cancelled, so 5, and here it is 8, here also 8. So x is equal to 5, y is equal to 8, and z is equal to 8. So therefore cost of onion per kg is 5, cost of wheat per kg is 8, and cost of rice per kg is 8. Okay, that's it. If you have any doubts, mention it in the comment box.
Like, comment, share, and subscribe.